In this video, we are going to introduce the idea of finding the tangent of an angle. So let triangle ABC be a right triangle with acute angle A. The tangent of angle A, written as TAN for tangent and then A, is defined as follows. The tangent of angle A is equal to the length of the leg that is opposite angle A. So here's angle A, this would be your opposite, all over the length of the leg that is adjacent to angle A. So we have opposite over adjacent. And there's a neat little idea that I want to introduce to you at this moment. And that is this idea, TOA. This T is going to stand for tangent, and this O stands for opposite, and this A stands for adjacent. And there's this really neat little saying that you'll hear in almost every geometry classroom, and it is Sohcahtoa. And Sohcahtoa is just a way to help you remember the different relationships. So in this part here, this is trying to tell you that, hey, my sine is my opposite side over my hypotenuse. And the ka part, the C stands for cosine. So my cosine is my adjacent side over my hypotenuse. And the one we are really focusing on is right here, the TOA. My tangent is a ratio of my opposite side over my adjacent side. Using the tangent ratio, a trigonometric ratio is a ratio of the lengths of two sides in a right triangle. All right triangles with a given acute angle are similar by the angle-angle similarity theorem, so triangle JKL is similar to triangle XYZ. Notice that I have right angles in both of those triangles, and I have angle J congruent to angle X. And you can write KL over YZ, so KL over YZ, is a ratio of this to this, is equal to JL over XZ. So JL over XZ. This could be rewritten as KL over JL, KL over JL equals YZ over XZ. So let's take a moment and let's just talk about this real quick. So this first proportion here, this is coming from the idea of ratios of corresponding sides of similar triangles are proportional. So when I'm talking about my KL, and let's color code this. So here's KL, and YZ is right here. In both of these triangles, KL and YZ is directly across from the marked angle, the angles that are congruent. So in these similar triangles, I would refer to these as my ratio of my corresponding sides, KL over YZ equals, and then in this next ratio, we have JL, which is right here. Well, let me change my color. So there's JL and over XC. And in both of these triangles, that is the side that is adjacent to the marked angle here, the angle J and the angle X. So once again, we have a pair of corresponding sides. So my ratio of my corresponding sides has to be proportional. So the ratio of KL to YZ is equal to the ratio of JL to XZ. Now, when they rewrote this, notice that the cross products didn't change. So when you take a look at these cross products, this is KL times XZ. And that's exactly what the cross products are here. KL times XZ and JL times YZ. And that's exactly what you have here. So rather than jumping from this triangle to this triangle and making the ratio, they just stayed within the same triangle. They said, okay, KL over JL is the same thing as YZ over XZ. Once again, you can verify that these are equivalent by taking a look at the cross products and seeing that you end up multiplying the same things. which is a trigonometric ratio. So trigonometric ratios are constant for a given angle measure. The tangent ratio is a trigonometric ratio for acute angles that involves the lengths of the legs of a right triangle. So your tangent ratio, let triangle ABC be a right triangle with acute angle A. The tangent of angle A, written as tan A, is defined as follows. It's the length of your opposite over the length of your adjacent. In the right triangle above, angle A and B are complementary. So angle B is acute. Remember that complementary just means you have two angles that are adding up to be 90 degrees. You can use the same diagram to find the tangent of angle B. Notice that the leg adjacent to angle A is the leg opposite angle B. So let's take a look at that. The leg adjacent to angle A. So here is angle A, and this is my leg that is adjacent to angle A. That is the same as the leg that is opposite angle B. And the leg opposite angle A is the leg adjacent to angle B. So make sure, so leg opposite angle A. So here's A, there's the leg opposite angle A. With respect to angle B, that would be my adjacent side.